In this video, we're going to talk about how neurons communicate. So in the drawing, I have 3 neurons drawn. This is not what they actually look like, obviously, just a representation, and then these dots is just continuation of the whole network. So this blue thing is called an action potential. It runs through the axon to the neuron in front of it, and I'll explain what the little plus sign is. So an action potential is an electrical impulse that moves through an axon. It is basically an inflow of positive ions, which is what this means. So if positive ions flow in, and an electric impulse moves through the axon. So as it says here, if too many positive ions flow in, the action potential will start. Now, ions are electrically charged atoms. It can be positive or negative. In this case, here it's positive. And there's something called a resting potential. We had an action potential where positive ions come in, and then the neuron sends a message. A resting potential is when positive ions are outside the neuron, like this, and negative ions are inside the neuron. And in that case, the neuron will not fire. It'll just be resting. So that's called resting potential. There's also something called a refractory period where there's a resting pause period after an action potential has moved through the axon. And in that period, another action potential or another signal cannot be sent. This usually lasts 1 to 2 milliseconds, and in this time, in this refractory period, the positive ions are pumped back out. So now to explain this all for you, here are a few more important concepts. There's a concept called threshold, where threshold is the minimum amount of positive ions that are needed inside the neuron to cause an action potential. And an all-in-one response means if the threshold for positive ions inside the neuron is met, then the neuron fires. If the threshold is not met, it rests. So there is no in-between. There's no half fire. There's no strong fire. There's no weak firing of a neuron. It's just firing or no firing. Now here's where we kind of try and put it all together. Normally in the resting period, right, in the resting potential, there are a lot of negative ions negative ions inside the neurons, and a lot of positive ions outside the neurons. So that's what's called resting potential. However, if we move just a little bit towards positive, and we have some of these positive ions move into the neuron, it's going to reach a threshold where it's going to activate its action potential. And when the action potential is activated, when it's activated, like a electrical impulse or a message will be sent down the axon, and that will cause this axon, it'll cause the ions from outside to go in, which will then fire this one, and then if you had more neurons, it just go on and on. So that's how the chain reaction starts. Now, you also need to be familiar with something called excitatory neurons versus inhibitory neurons. So if this neuron, the red one, fires, it's going to cause this one, it's actually going to cause negative ions to move into the neuron. If you have negative ions move into the neuron, it's going to make it harder to fire. It's going to move it away from action potential and more toward resting potential, even below resting potential. But if the excitatory neuron, which is the green one, it's going to send excitatory impulses, meaning that if the impulse of this one is stronger than the impulse of this one, we're going to move in this direction, and you could potentially have an action potential if there's enough excitatory signal.